All right, next we're going to talk about the average value of a function. And what we want to do is first start off by looking at the mean value theorem here. And remember how we said that the average value of the function was that f of c. And so if we want to find the average value theorem, we could basically solve for this by dividing by b minus a. Okay, and we would do that on both sides. And all that leads us to is the definition of the average value of a function on an interval. So again, if f is integrable on the closed interval a to b, then the average value of f on the interval is this right here. And so just take the step from dividing by b minus a, and it's the same as multiplying by 1 over b minus a. Essentially the same thing. And it gives us that average value which we had been dealing with as f of c. Okay, so again, this is very much related to your mean value theorem. So if we have our interval from a to b of whatever function it is, then this equation right here is going to give us our average value right here at f of c. So the drawing looks very similar, except in this case we're using that theorem to find our average value. Example 5, it says find the average value of the function on the given interval. So here we have at 3x squared minus 2x on the interval from 1 to 4. So we want to go from here to here, and we want to find the average value. So we can actually just write it now as f of c equals 1 over, now the difference in the interval, so 4 minus 1, times the definite integral from 1 to 4 of 3x squared minus 2x dx. Okay, so here 1 over 4 minus 1 is 1/3. And let's go ahead and find the antiderivative of 3x squared minus 2x. So it's going to be x cubed over 3, and our 3's are going to cancel. So we're really left with just x cubed here. And then minus 2x, so it's going to be x squared over 2, and the 2's will cancel. So it's minus x squared. And this needs to be evaluated then from 1 to 4. Okay, so we'll keep the 1/3 here. And we're going to substitute in 4 for x. So we have 4 cubed minus 4 squared. And then minus, let's substitute in 1 for x. So we get 1 cubed minus 1 squared. Okay, and this is going to be 1/3 times this actually here, 1 cubed minus 1 squared. That turns out to be 0. And this turns out to be 48. So we have 48 minus 0. So it's really 1/3 times 48, which is 16. Okay, so again, what that tells us is the average value of the function on the interval is 16. So if we look across, that would give us our average height. Now, let's go ahead and just find what our value of x would be. Okay, that corresponds with that, just as a little bit of extra practice. So what we would do is we would take our function, which is 3x squared minus 2x, and we would set it equal to 16, and we'd say, well, what x value is going to give us 16 there? Okay, and to solve this, we go back to our algebra 2 methods, and we're going to let this equal 0, so subtract 16 to both sides. So we get 3x squared minus 2x minus 16 equals 0. And then we're going to try to factor this. 3 really can only be a 3x times an x. That's our only possibility. Okay, so now we need two numbers that multiply to negative 16, and when we check our outside and insides, okay, it has to equal the negative 2x. So just recall FOIL. So the firsts have to give us the first, the outside and inside have to give us negative 2x, and then the lasts have to give us negative 16. So let's just try something. We could try something like 8 and 2. So let's just do plus 8 minus 2, and then check our outside inside. So this would give us 3 times negative 2 is negative 6 plus 8. That gives me positive 2. Okay, so maybe we want to change the signs there. So let's try negative 8 and positive 2. Now we have 6 minus 8x gives us negative 2x. Okay, so our two solutions here, this one would give me the solution of 8/3, and this would give me the solution of negative 2. So if we wanted to find the value of c, well, which one would it be? Would it be 8/3 or would it be negative 2? Well, negative 2 is not in our interval, so it can't be that one, meaning this has to be at 8/3. And if we look, we estimate that that would be just about right, because 9/3 would be 3 right there. All right, it turns out that this also works for trig functions. So we want to find the average value of the function of sine x on the interval from 0 to pi. So we have this drawn here. Okay, I want you to try example 5 on your own. Go ahead and find the average value of the function, so find f of c, and then see if you can find the value of c that will give you the average value of the function. Go ahead and pause the video, and then come on back to check your work. All right, welcome back. So to find our average value, you should have used our average value formula. So 1 over pi, and pi is the width of that interval, times the definite integral from 0 to pi of sine x dx. And the integral of sine x is negative cosine x. And if we evaluate this from 0 to pi, we'll plug in pi first, and then in 0, and then subtract them. So you really get 1 plus 1, or 2 over pi. So the average value of the function is 2 over pi, and you can see that is right about here. It's about 0.64. Now in this case, you'll notice that we get two solutions here. So there are two places actually where this function equals its average value. So to find that, we just set sine c equal to 2 over pi, and then to get c by itself, we're going to take the sine inverse. Okay, so c equals the sine inverse of 2 over pi, and that's going to give us this first value right here. Now because this is symmetrical, you can kind of see between 0 and pi, it's going to be symmetrical, so this same distance right here is also going to happen right here. And so we can also do pi minus the sine inverse of 2 over pi to get our second value there. Okay, and when you calculate this, you get about 0.69 for the first one, and about 2.45 for your second solution. Okay, so this is how to find the average value of the function on a given interval, and then also to find which c values give you that average value of the function. All right. Now this question is a little bit different because our function now is not really given by an equation. It's just given by this line. And go ahead and fill in these dots because this is a continuous function. Otherwise, this doesn't work. Okay, so we have our continuous function f of x, and it's given by this graph right here. What we want to do is evaluate the definite integral from 1 to 7 of our function. So we can go ahead and draw our interval. We want to find the area under here. So we can break this up into 3 geometric shapes. Okay, so if we look here, this would have an area of 6. Okay, if we looked at this one, this would have an area of 1, okay, because it's 1/2 base times height. So it's 1/2 times 1 times 2, which is 1. And then this area, so the base here is 2 times the height of 1 divided by 2. It also has an area of 1. And so the area here is going to be 8. And we just added it up geometrically. So based on that, determine the average value of f on the interval. So what we're trying to do again is find what's the average height over that entire function on that interval. Well, we know that f of c, or the average value, is going to be 1 over, well, the interval width, so 7 minus 1, times the definite integral, which is going to be 8. So we get 1 over 6 times 8, okay, which is 8 over 6, or 4/3. Okay, so if we look here, 4/3, that gives me the average value of this function. So repeat parts A and B above if the graph is translated 2 units upwards. Okay, so now this whole thing gets shifted 2 units upwards. And we'll just call this function like g of x. So what would be from 1 to 7 of our g of x now? Okay, well, all it really did, we still have this amount of area, so it's still going to be from 1 to 7 of f of x. And all we're going to do is add on 2 times 6, which would be the area of the extra rectangle that gets added on there. And so this would actually turn out to be 8 plus 12, or 20. Okay, and if we want to do part B, determine the average value, okay, we're going to find g of c, and so it's going to be 1 over 6 times 20. So in this case, we get 20 over 6, which is 10/3. Now what we can do, let's compare these two right here. If we shift this entire function up 2, what do you notice happens to the average value of the function? Well, the difference between 4/3 and 10/3 is 6/3, which is 2. So we can see here that when we vertically shift a function, it also shifts the average value by that same amount. And it would be 2 higher. So just kind of an interesting side note there. Alright, so that is how you find an average value of a function on an interval.